Now sets. We call sets as an expression that cannot be written or simplified to get an exact value. So most of the time we say that if I have root of 2 is a set, just because we are saying that sets are root of all prime numbers. 2 is a prime number, 3 is a prime number, so root of 3 is a set. 5 is a prime number, so root of 5 is a set. 7 is a prime number, so root of 7 is a set. Now with these expressions, when you punch these expressions on the calculator, you wouldn't get an exact value. You get decimals. That's why we are saying that sets are expressions that cannot be simplified to get an exact value. Now let's look at this theorem. Let's say given any two numbers, let's say I have 4 here and I have, let's say, 11. Now the square root of 4 will give me 2. When you punch square root of 4, you get 2. But when you punch square root of 11 on the calculator, you get 3.3166 in that order. So since we are not getting an exact value, we see that root 11 is a set. So we say that this is a set, but root of 4 is not a set. It's not a set because when you punch this on the calculator, you get an exact value. See, 2 is an exact value, but root of 11 gave us 3.3166. We have a whole lot of figures there, so making root of 11 not a set. Okay, making root of 11 a set and root of 4 not a set, because root 4 is giving us 2 and root of 11 is giving us this figure. So the root of 11 is a set, but root of 4 is not a set. The same thing applies to these values. Root 2, root 3, root 5, root 7. All these are not set. All these are not set. Now, because we are looking at this, let's take a look at one aspect of set we call perfect square. Now, perfect square is saying that if you have an integer, let's say an integer 2, and when 2 multiplies itself, you are getting another integer, let's say 4. Now, because 2 times 2 is giving us 4, because two same integers are giving us 4, we say 4 is a perfect square. So if you have two integers whereby the result of these two integers are giving you another number, the result you get becomes a perfect square. So let's say 1 times 1 equal 1. So we say 1 is a perfect square. 3 times 3 equal 9. So we say 9 is a perfect square. 4 times 4 equals 16. So we say 16 is a perfect square. So why is 16 a perfect square? 16 is a perfect square because 4 times 4 will give you 16. Now, 2 is not a perfect square. Two is not a perfect square because there is no number on this earth that when you multiply, you can get 2. No number on this earth can multiply to get you 2. So we say 2 is not a perfect square. But a number, say 25. 25 is a perfect square because 5 times 5 is 25. 64 is a perfect square because 8 times 8 is 64. 81 is a perfect square because 9 times 9 is 81. 49 is a perfect square because 7 times 7 is 49. 100 is a perfect square because 10 times 10 is 100. 121 is a perfect square because 11 times 11 is 121. 144 is a perfect square because 12 times 12 is 144. So that's how it works. And again, 169 is a perfect square because 13 times 13 is 169. So the reason why we are saying that all these values are perfect square because two same integers are given as this. But no same integer, no number can multiply itself to give you 2. That's why I'm saying that 2 is not a perfect square. So if 2 is not a perfect square, then the root of 2 becomes a third. 3 is not a perfect square. So therefore the root of 3 is a third. 5 is not a perfect square. So therefore the root of 5 is a third. 7 is not a perfect square because the root of 7 is a third. Now the next aspect we are going to look at is simplification of sets. Now under simplification of set, when a question is given to you, a question say simplify without using calculators. So let's look at this first question. Let's say root of 12. Simplify root of 12. Simplify root of 12 means that you are going to look for two numbers that when you multiply you get 12, of which one of the number should be a perfect square. Now we believe that root of 12, the number 12 here, we believe that 12 can be 4 times 3. 12 again can be 6 times 2. 12 again can be 12 times 1. Now, out of these three cases, you are going to pick the statement that is giving you 12, of which one of the number is a perfect square. Now, when you pick the first statement, 4 times 3 is 12. Very good. If 4 times 3 is 12, is 4 a perfect square? If yes, we will use this statement. If 3 is a perfect square, we use this statement. When you come to the second statement, 6 times 2 is 12. Ask yourself, is 6 a perfect square? No, 6 is not a perfect square. 2 is not a perfect square. 12 times 1 is 12. Is 12 a perfect square? No. So since these two numbers, since this and that are not perfect square, 12 is not a perfect square. Fine, though 1 is a perfect square, but we can't use 1. 12 times 1 is still 12. If not done anything. So we are looking for two different numbers that when you multiply you get 12, of which one of the number is a perfect square. So we are going to pick this. So we say that root of 12 is equal to root of 4 times 3. It's the same thing. You've not changed the question. Now as soon as you get here, we are going to split this statement into two. 4 will get its own root. 3 will also get its own root. Now root 4. Since 4 is a perfect square, so the root of 4 is 2. Root 3, you can't do anything to root 3 because 3 is a prime number. So 2 times root 3 is the same as 2 root 3. And this is the same as root of 12. Now when you punch this statement on the calculator, this is the answer that you get. If you get a different answer from the calculator, it means you are wrong. The next question you are going to consider, let's look at root of 18. So root of 18, you want two numbers that when you multiply you get 18, of which one is a perfect square. 9 times 2 is 18, 6 times 3 is 18, and 18 times 1 is also 18. So we are going to pick the statement that gives us 18, of which one of them is a perfect square. Now when you look at these three statements, you can see that 9 is a perfect square, 6 is not a perfect square, 18 is not a perfect square, 3 here is not a perfect square, 2 is not a perfect square, but since 9 is a perfect square, we are going to pick the first statement. So we have root of 18 equal 9 times 2, all roots. After that, you are going to give each of them a single root, So root of 9 is 3 times 3, because 3 times 3 will give you 9. So root of 9 is 3, root of 2, and the final answer is 3 root of 2. Now the next example we are going to consider, let's say root of 20. We want two numbers that when you multiply you get 20, of which one of them is a perfect square. Now 10 times 2 is 20. Again, 5 times 4 is also 20. So out of these two statements, and again 20 times 1 is also 20. Out of these three statements, you can clearly see that 10 is not a perfect square. No number on earth can multiply itself to give you 10. And no number on earth can multiply itself to give you 2. No number on earth can multiply to give you 5 and 4. 4 here, there is a number that when you multiply it by itself, you get 4. So you are going to pick this statement rather to satisfy this condition. So root of 20 is equal to root of 5 times 4. After that, you split this into 2, root of 5, root of 4. Now root of 5 is still root of 5. You can't do anything to it. And root of 4 is 2. So therefore, root of 5 times root of 2 is 2 root of 5. Don't multiply this one and that. No, it's wrong. Root of 5 times root of 2 is 2 root of 5. Now the next thing you are going to consider, let's say root of 75. Root of 75, we can think of 25 times 3. 25 times 3 is 75. And 25 is a perfect square, so we can use this. So root of 75 equal 25 times 3. After you split it into 2, now the square root of 25. The square root of 25 is 5. So therefore your final answer is 5 root of 3. And that's your answer. Now the next example is the square root of 162. Now the square root of 162 is coming from, you can think of 81 times 2. 81 times 2. We have 81, we have 2. The square root of 81 is 9. 2. So we leave it like this. Now our next example, let's look at these cases. Let's say we have 2 root of 27. We have to simplify this. 2 root of 27 is the same as 2 outside and root of 27 into brackets. So we have root of 27 can be 9 times 3. Because 9 is a perfect square, that's why we're using 9 times 3. And here we have root of 9 and root of 3. This is just like the previous one, but here in this case, you see we have 2 attached to the root sign. That's why we are using this square bracket, so that it will not affect what we are doing in the square bracket. So root of 9 is 3 times root of 3. So we have here 3 times root of 3 is 3 root of 3. Now after that, after you arrive here, you can now multiply this by what you have here. But these two cannot multiply what we have under the root sign. It can only multiply the number standing beside the root sign. So 2 times 3 is 6 root of 3. And that's the answer. The next example we are going to consider is, let's say, 5 root of 200. So the same approach, root of 200. Root of 200 is the same as 100 times 2. And we have root of 100 times root of 2. Root of 100 is 10, root of 2. And we have 5, 10 root of 2. Now 5 can multiply 10. So 5 times 10 is 50 root of 2. Then you leave your answer like that. The next thing we are going to consider is, let's say, negative 7 root of 32. So we have negative 7 here and root of 32. Negative 7 still stands outside, and root of 32 can be 16 times 2. We have root of 16 times root of 2. Root of 16 is 4. And from here, we have negative 7. 4 times root of 2 is 4 root of 2. So as soon as you get here, this negative 7 can multiply 4. So we have negative 28 root of 2. And that's your final answer. Now the next thing is 3 on 5 root of 48. So we let 3 on 5 stay outside. We have root of 48 here. Now root of 48 can be 16 times 3. So we have 3 on 5 here. We have 3 on 5 here. And we have root of 16 times root of 3. So we have 3 on 5. Root of 16 is 4. So we have 3 on 5 still outside, and 4 times root of 3 is 4 root of 3. Now the 3 on 4 can only multiply this number here. So 3 on 4 times 4 is the same as 3 times 4 all over 4 root of 3. And 3 times 4 is 12 all over 4 root of 3. Now this 4 can cancel this. So you'll be left with 3 root of 3. And that's your final answer. Or if possible, from here, as soon as you get here, this 4 can cancel this 4. Then you'll be left with 3 root of 3. It's still the same thing. Now the next example, let's look at it. We have 2 whole number 1 on 3 root of 98. So we can rewrite this thing. Now this is just a mixed number. You can change it to improper fraction. So we have 7 over 3 root of 98. Now 7 over 3 root of 98 can be, let's say, 49 times 2. So we have 7 over 3. That's root of 49 times root of 2. So we have 7 on 3. And root of 49 is 7 times root of 2. Now we have 7 over 3. 7 times root of 2 is 7 root of 2. Now because 3 cannot cancel this, so 7 times 7 becomes 49 all over 3 root of 2. Then you leave your answer as it is. It's 3 whole number 5 on 2 root 8. We have to simplify this. This is just a mixed number, change it to improper fraction. So 2 times 3 is 6, 6 plus 5 is 11. So we have 11 over 2 root of 8. So you have 11 over 2. Root of 8 is the same as 4 times 2. 11 over 2. And we have root of 4 times root of 2. So we have 11 over 2. Root of 4 is 2. And we have 11 over 2. 2 times root of 2 is 2 root of 2. Now these 2 can cancel these 2. So you'll be left with 11 root of 2. And that's your final answer. So on that note, you are going to try this simple example so that you confirm your understanding. So we have these examples here: root 1 to 8, negative 2 root 5 root 75, 8 root 8, 4 whole number 1 over 2 root 8, 2 third root of 168, and negative 4 root 50. So try these examples.